It's an exam question about a competitive inhibitor. It says figure 3.2 shows the effect of increasing the concentration of the substrate, and we've got a substrate called PABA, on the rate of reaction. Curve A shows the rate of reaction without the presence of the competitive inhibitor, so we're told that it's a competitive inhibitor, and the name is sulfonamide. Curve B shows the rate of action in the presence, so A is without, B presence of the competitive inhibitor. We've then got the graph where we've got rate of reaction, the concentration of the substrate, so PABA, and then that's A is without and B with the inhibitor, and see we've got two graphs. This is an image of the structure of PABA, which is this is the substrate, this is the inhibitor, sulfonamide, and you can clearly see that they are very similar in structure. They both have got a hex, a 6-carbon ring. They both have the amine groups, and therefore they'll both be able to enter the active site. We'll say that they're both complementary to the active site because they'll both be able to fit in the active site. So that's why sulfonamide will act as a competitive inhibitor. So we have to talk about, it says explain the effect of increasing concentration. So we've got to talk about what happens as we go along this graph on the rate of reaction. So that's important. We've got to talk about the rate. So let's start with this. Part one is without the inhibitor. So without the inhibitor is line A, and if we look at A, as we increase the concentration of the substrate, the rate of reaction is increasing, and that's because more PABA, because we've only got the it's no inhibitor, so there's no inhibitor around, so it's just PABA available. So more PABA will enter the active sites as we increase the concentration of PABA. So we can start by saying that. So more PABA. So more PABA molecules enter the active site. It is important that we mention the active site, and that's because PABA is a complementary shape to the active site. Therefore, there's more enzyme substrate complexes formed. Don't forget we're talking about more because this is about what's happening as we increase the concentration. Right, if we look at the graph at low concentrations, it's a low rate of reaction, and that's because not all the active sites are occupied. So at low concentrations, not all active sites are occupied. As we continue to increase the concentration, you can see that we reach a maximum rate. So this maximum rate is Vmax, and that's the maximum turnover rate. So that's how many products are made per active site per unit of time. So we can say that. So that it reaches maximum turnover rate, which is V max. And that's when there's a high concentration level, so that's at a high substrate concentration level. What we don't want to say here is that active sites run out. We've got to say that all the active sites are occupied at high concentrations, or they're not occupied at low concentrations. When we're talking about Vmax, don't say it levels off. And don't say it's the optimum rate. We want to be talking about Vmax. I forgot to say here, at low concentrations, not all the active sites are occupied. At high concentrations, all active sites occupied. Okay, so that's explaining what happens to the rate of reaction without an inhibitor. Just go through that one more time. At low concentrations, not all the active sites are occupied, so we've got a low rate of reaction. As we increase the substrate concentration, more PABA molecules enter the active site, so we've got more enzyme substrate complexes formed, so increasing rate of reaction. Eventually, at high concentrations of PABA, we reach Vmax, and that's when all the active sites are occupied, and therefore we've reached the maximum turnover rate of the enzyme. Right, the next part of the question, we've got to explain the effect of increasing concentration with an inhibitor. So on the graph now, this is part B, and we can see that it's not the same line as without an inhibitor. So we've got to explain what's going on here. So with an inhibitor, as I said before, the sulfonamide is a similar shape to the active site, therefore it can fit into the active site. So we need to say that. So the inhibitor can fit, or it binds to, the active site. Again, we need to make sure we're mentioning active site, and therefore there's fewer active sites available for PABA or the substrate, and therefore that's why the rate of reaction, even though we're increasing the concentration, it's a much lower rate of increase. However, as we continue to increase the amount of substrate, the rate is starting to get towards Vmax. Therefore, more substrate must be binding with the active sites. And that's because the inhibitor only binds for a short time. It's reversible. And the more we increase the substrate concentration, that reduces the chance of the inhibitor binding with the active site. So more substrate reduces the chance of the inhibitor binding with the active site. You could say there's more enzyme substrate complexes formed rather than inhibitor substrate complex, enzyme inhibitor complexes. In effect, the substrate outcompetes the inhibitor. So we have 5 marking points for a 2-mark question. Let's just go through that one more time on the graph. So as we can see from the graph, at low concentrations, there's lower rate of reaction than with and without inhibitor. That's because the inhibitor is complementary to the active site, so it binds and fits to the active site, so fewer active sites available for the substrate, therefore lower rate of reaction. As we increase substrate concentration, the substrate starts to outcompete the inhibitor because there's more substrate, therefore more chance of the substrate binding to the active site, less chance of the inhibitor binding to the active site. So therefore more enzyme substrate complexes formed, and therefore as we continue to increase the substrate concentration, we'll eventually get to normal rate of reaction where we're going to head towards Vmax.